Hello guys, in this video I'm going to show you how to solve all root to leaf paths problem. So this one is in depth of search category. Given a binary tree, return all root to leaf paths, right? So as you can see here we have a binary tree. There are 3 levels in totals. So the expected output will be all root to leaf paths, right? So the first part is 174 is the first one. The second one is 175. 175. The last one is next one is 192, and the last one is 197. Okay, that total of 4 parts. We need to return as an output, right? So this one is pretty similar with the previous one, which is all parts for sum. This one is even simpler because we don't need to calculate the sum of each part, right? We just need to save all the parts. So for all these problems that requires you to to print part or calculate sum from parts, then think of depth of search, right? So as you can see, we can a path is actually as a way to travel the tree from root to leaf, right? So let's try to solve it, right? Depth of search, right? So let's before coding it out, let's try to run through the algorithm manually. So okay, let's say okay, we start root node, right? And okay, so at each visited node, we try to probably want to keep track of the current path, right? Because we want to use recursions for traverse the tree in depth, right? So we need to keep track of the visited node, right? So we start at 1, right? Let's say we have a current so we start at 1. Okay, so we visit 1. We want to keep track of that node to our current part, right? Current part. Okay, so at 1 there's two choices here, either go left or either go right. So for depth first search we go left first, right? So now come to 7. I'm gonna simulate the stack code, right? So here is the recursive functions. For the first one, we pass in the node, which is 1, right? So there are two choices. We go left, so we call DFS 7, right? At 7, keep track of for every node, right? We keep track of 7. Again, at 7 we have two choices here, which is 4 and 5. So we go left first, right? DFS 4 174. Okay, here is here, as you can see, it's a leaf node already. We know that because both left and right is empty, is null. So for the leaf node, we probably don't want to stop, right? Because a path is just a list of nodes from root to leaf, right? So we are leaf now. So we end the current path here, right? So we probably want to push this into a result, right? Let's say all. Okay, we're done with the current path, right? So leaf node, we're done. So we pop it out from the stack code, right? So here, as we pop out from the stack, we also want to pop it out from the current path, right? Okay. So we come back to 7, as you can see. We come back to the functions DFS 7, right? So at 7, we have visited 4 left tree, left node, right? Which is 4, and we have 5 left that is not visited yet. So we go right, So DFS 5. Okay, DFS 5. We visit 5, so we put 5 to the current path. Okay. 5 is a leaf node, so we're done with the current path. Push the current path to the result, right? So okay, so we're done at 5. So cycle is here's a cycle. So we come back to 7, and now at 7, okay, we're done with 5, so we pop it down from the stack. Yeah. At 7, we've done traversing left and right, 4 and 5. So we're done at 7, right? We come back to 1, pop out DFS 7, right? At the same time, so after pop 7, we pop 7 from the current path also, right? We come back to 1. We've finished with the left part, right? Left subtree, and now go to the right subtree. We go to DFS. We go to node 9, so DFS 9. Okay. we visit 9, so push 9 to the current path. Okay, at 9 there are two choices. We go left first, DFS 2, push to the current path, right? So 2 is the leaf node, so push whatever the current path is. We have a new path, right? Okay, so to the leaf node, so we can't go further down, so pop it down, pop from current path also, right? So we come back at 9. Now we visit the right of 9, which is 7, DFS 7, right? Okay, we visit 7, so push 7 to the current path. 7 is the leaf node, so push the current path to the okay. So we're done at 7. Pop out. Okay, we come back to node 9. Okay, at 9 we visited left and right already, so we're done here. So pop 9 out. Okay, pop 9 from the current path. Okay, we come back to 1. So at 1 we visited left and right, so we're done. Pop out, and stack go is empty, so we're done. So here is the result, expected output, right? So that's pretty much it about this algorithm. Let's try to turn it into code, right? Want to use as you can see, we need to keep track of two pieces of states between stack goals, right? The first one is current node, right? The current node, the current path and the result path, right? Let's say I'm gonna use another class, solutions. This one has DFS, right? So the thing that is changing between stack goal is a node, right? So we need to keep track of between recursive calls. We need to keep track of constructor. We need current path, right? Is an array. This dot is an array also. Okay. So DFS means we are visiting the node, right? We are visiting the node. So initially, want to visit the first node, which means the root, right? So I'm gonna return a new solution, create a class, right? So DFS pass in the root, which is the first node to visit, and this one will finally return this.all, which contains all the paths from root to leaf, right? So okay, so here we are visiting the node, right? It can be any node in this tree, and the first one is of course root node. So for each visited node, we want to keep track it into this current path, right? push it in node.found, which is a value. Okay. For the recursive, we need to have a base case, but let's handle it later. Base case, right? So for each visited node, we keep track of the node, right? Then go left and go right. Gonna use a for loop here. For child, let child of okay, node.left and node.right. Gonna visit left and right. But only if the child here is left or right, right? So only if the child is not no, then we want to visit. Otherwise, we don't want to visit the no node, right? Because if it's no, when we're accessing the val here, so if child, okay, not no, we revisit it. Okay, we visit it by calling recursively, but passing a node that we visit, which is child. Okay. Okay. So we're done with the traversing part. Now come to the base case. So when this is gonna stop? This is gonna stop when we reach when it reaches the leaf node, right? A node is a leaf node when both left and right is no. So if node dot left node, right, and we don't have a node dot right, so it means we're at leaf node now. Okay. So for leaf node, it means we done traversing one part, right? So we want to save the current part to all, right? This dot all dot push. Here is one thing to notice. We don't want to push this one because array in JavaScript is a how to say, it's passed by reference, right? So as you push here, it is a reference. If you do something like this dot current path, it's a reference to this variable, this the actual data. So later when we modify this current path, the one that the data in the path, right, that we have pushed to this one will also be changed, right? So be careful, we don't want that happens. So we use a new array and we spread all the value. So if it is leaf node, we push here and return. We return to the previous code, right? As we've explained earlier, right? So one thing is missing here, which is after we finish traversing the child, which is either left or right, we want to pop out the child's value, pop it out from the current path, right? This dot current path, pop. Okay. What is there anything that we need to consider here? I think that's pretty much it. Right? Let's run it now. Just 8. Okay, 2.1. Come on. What's went wrong? What's wrong here? Return new solutions. Okay, push everything. We not current path. Not found. Not sure what is missing here. As you can see, here is okay, child not that. If we have child, we go left. Left or right. Have we done here? Pop it out for the current path. This is not all. If we leave not, it means we don't have left and right. So we push everything. The current path. So I can't see anything wrong here. Child of this right here. Let's try to debug it. Let me see. Okay, not sure. Okay, we go to DFS. So we have first score. Okay. Node.var is 1. Okay, the kernel is 1, right? It's not a leaf node, so we push val to kernel path. This dot kernel path. This dot all. Okay. Kernel path is 1. Okay, because left and right. We have both left and right. Child here is come on. Child.lab val. Okay, so we go lab 7. Okay, we enter a recursive call. Okay, it's not leaf node. Record 7, so we're visiting it. Okay, again we go lab, which is 4. Okay. What's wrong here? It's a silly mistake here. At the leaf level, we will not we end it before we push the value to current path, so it's missing, right? So one way to fix it is to move it forward, right? So we push. So if we leaf level, we want to push the current value to leaf to the current path first before we push the path to the result. Okay, it should be working now. Okay, so that's it for this one. Sorry for silly mistakes. Thanks for watching and see you in the next one.